once I have that side set up, I try and set up the other side of the equation, and I need a third angle here because I need to use this 25 meters, and so I need to figure out what angle C is there. So if I have two angles inside of a triangle, how do I find the third one? Do 180 minus. So 180 minus 97 minus 38, and I get 59 degrees. So this becomes sine of 59 degrees. And now I go ahead and say, okay, I gotta multiply both sides by sine of 83 degrees. Both sides by sine of 83 degrees. AC equals 25 times sine of 83 over sine of 59. All right. And now I can go ahead and plug that into my calculator and solve for side length AC. Okay. Now problem 2 was a law of cosines problem. Are we still here? Good. So problem 2 was a law of cosines problem. So for this one, what I need to do is I need to say I'm looking for side length C, or I could say side length AB, and we'll say side length AB squared, or we could think about it as C squared equals A squared plus B squared minus 2AB cosine of C. The most common mistake I see students make here, whoops, lost it. So what I need to do then is finding this missing side length. I have side length AB squared, so the other side's A squared would be the 19 squared. The B squared is 27 squared. Those are pretty interchangeable too. It doesn't need to be the exact same sides. And then times 19 times 27. And then cosine of 80 degrees. All right. And then from there I can go ahead and just put these certain parts into my phone and figure out what those values are. And then we square root both sides, and we'll get side length AB. And I think it came out to like 30.1 or 30.2 meters, something like that for side length AB for problem 2, using the law of cosines, finding that missing side length. Okay, that was the idea for this one. Oops, sorry, yeah, you can't see my screen yet. Thank you. Sorry about that. The little power surge, lost power, and then had to figure out how to get the internet back on. So problem 3 was another law of cosines problem. This one though is where we're looking for an angle measure. So it's going to be, whenever we're looking for the angle measure, we're going to have to do the inverse trig, which we have that in our notes. But we'll have to say cosine of C equals A squared plus B squared minus C squared over 2AB. So A squared in this case, remember A and B are kind of interchangeable. It's 9 squared plus 6 squared minus 14 squared over 2 times 9 times 6. All right, so 9 squared is 81. 6 squared is 36. 14 squared is 196. And then 2 times 9 is 18. 18 times 6, 108. So now for this one, I think we end up getting, was it negative 79 over 108? And then we plug that into our calculator and figure out what measure of angle C is. What did we get for measure of angle C here? I think it came out to like 100 and something degrees. What did we get for this? What did you guys have for this one? I think it came out to like 130. I could be wrong. 137, perfect. 137, and it was like 0.0 degrees. So Since we're rounding the nearest tenth, we'll just keep it as the 0.0 there. And then last problem here, a law of sines problem. I'm looking for the measure of angle C, so I'm going to set up the sine of C over 11 equals sine of 98 degrees over 19. So I can tell you angle C is going to be smaller than 98 degrees. All right, you can tell that just based on the side lengths alone. But we'll get sine of C equals 11 times sine of 98 degrees over 19. And then we take inverse sine of both sides. And you could definitely put it in your calculator first. That might be easier. And just get a weird decimal answer and then take the inverse sine of that. So I think it was like 11 times sine of 98, whoops. So 98 sine times 11 divided by 19. So we got some 0.5733 here. And then we just take sine inverse of that. All right. So go ahead and take, what do we get for the measure of angle C for problem 4 here? What do you guys get? It should be a small angle. I can't remember what it is off the top of my head. What was the last one? Measure of angle C, 34.8, thank you. 34.8 degrees. And we're rounding the nearest tenth because that was what was in the directions.